In this example, we are going to walk through setting up a spreadsheet, and we're going to use Google Sheets. It's free, readily accessible. So we're going to identify that area, calculate that volume from the example. Then identify and evaluate surfaces, adds absorption coefficients so we can find a total Sabins, average absorption, and then use the Sabin and Eyring equations to calculate what those RT60 times are in that space. So for the example, we're going to use this example. Dimensions are given here: 58 feet 4 inches by 33 feet 5 inches. But we'll set up a check system, and then further at the end of the presentation posted, you can do some checks on that. So let's go ahead and get started. I'm going to go ahead and switch over full screen and walk through this. So where you want to start, you want to go to Google Drive, set you up a profile up there. When you get there, go ahead and make you a folder, and we'll go ahead and start the Google Sheet. So it's a blank sheet. So where we're going to end up at is an example like this, where we have the data here for the project, and then calculating volume over here is based on what we enter here. So if we have a height of 10 feet, east wall is 10 feet, north wall is 10 feet, we get 1,000 cubic feet, which makes sense. And then if you want to add in you have a 5x5 area by 10 feet, that will chop out 50 cubic feet, or 250. So 25, 10, 250, we get 750. But that is not the basis of what we're covering today. We're going to figure out what this volume is in cubic feet, then using these dimensions here that we input for height: east wall equal to west wall, north wall equal to south wall. We'll use that to calculate what these areas are. So all 6 of those. And then add in absorption coefficients. We'll get our total Sabins. Oops. Those are then summed down here. Then from that, we get our average coefficients for each of those octave bands. We can use that to then pick what our materials are, decide if we need to take this up, down, figure out from this information, calculate what our Eyring and Sabin equations are, then set an existing, and then down here figure out what we need to add to that. So what do we need to add to the ceiling? What do we need to add to the north wall, east wall, south wall, west wall, the floor, to get to what we want for that goal, based on the space that we're doing. And that will help us, before we even build a model, to set what that target area is. So let's go ahead and get started from scratch. I will talk through the thought process as I go through here, starting from scratch, so that it's of help to you. I will do a little bit different in this aspect, so that We don't need a large volume equation to get that to feet, so we'll just do it to the side over here. So let's go ahead and get started. As with any tool you make, you want to give it a name. We'll call this calculation reverberation time. Do the same here. Go ahead and copy that. Go ahead and make that bold here. I don't really change any of these aspects. When I'm doing a tool like this, I'll do the majority of formatting once I've got the calculations done in the single spreadsheet that we'll cover in another video. So I'll put the data that we would have here. Oops. All the data that we would have over here and down here that the client would need, make a separate 8.5 by 11 report that has the information that the client would be interested in. And that would include room dimensions, room materials, area for each surface, volume of the space, RT60 for Sabin, airing, what our target is, and then what they really want to know, the needed reduction. So what do they need to add to the existing room to get that? Let's go back to our spreadsheet. We've got our title. We'll give a spot for the project, date, room, volume to follow that, and then we'll add in seating capacity. We'll take that out. And this formatting is just a personal choice. Bring all that over. So we'll call this project RCH 520 example. Double click there, take it out a little bit more. Date. We'll do some day and time. And room, we'll call this room first example. Let's just call it 106. Call it the lab. Or actually, this is dirt work, so let's call it third floor renovation. And I might actually switch this. Let's call it third floor renovation, and we'll call it first example. So we can track that, know that's the first example. And then we've got our seating capacity there. We want to give our unit over here. Our volume is going to be in cubic feet, and our seating capacity will be by person. So we've got the base information given there. Now the next portion that we want to do, we want to add in the input data. So I usually leave a space here, and we'll call this input. Make this bold. And you might want to make this area a different color or color those cells so you know what you need to put input in. And so we'll do height, east wall, north, west, south. And we'll do feet here, inches here. Let's shrink these a little bit. And we're not going to add the area to remove. We can add that later because we just want to get that volume and then start getting those areas down here. So I'm going to make this a light gray. Fill color, do a drop down, make this a light gray so I know the input in there. Also make this a light gray. Oops, that was actually... So we've got that. The good thing about using Google Sheets is that it automatically saves. But it's good to make a backup of this at some point in case you can't get into your drive, because you can open this in Excel or other spreadsheet files or programs. So we've got our input here for our dimensions. We want to take that to volume. So if we use 9 feet, 12 inches, that should return 10 feet over there, because we want to get this into feet and inches, because that's probably what we're going to measure in and not decimal, so we don't have to calculate that. So we'll have the tool go ahead and do that. And so we'll check this 9 feet 12, and we'll do north 9 feet 12, and this is just a check, so we know that we need to get 1,000 here. So 10 times 10 is 100 times another 10 is 1,000. So we'll do equal here because those will be the same, and then we'll do equal to north here. Go ahead and hit it. Now you might be asking, why are we even keeping this? Because the way we're going to do the formula over here is we're going to do an average of the north and south wall and then an average of the east and west wall. That way, if those are slightly different, or we don't have a square or rectangular room, we can still get a volume with it close. So right now we're going to set those equal based on what we're going to do in the formula over here. But we will we can override that if we need to change that in whichever way we want to do it. All right, so let's bring this in a little bit, and then we'll call this conversion 2 feet. Let's actually call this decimal conversion. And so what we want to do is we want to do an equal this divided by 12. So inches divided by 12 plus feet, and that should give us decimal form. And then we can go ahead and copy that all the way down. So we know that this is doing a conversion. We can add feet here. Go ahead and copy that all the way down. And then if we want to get fancy dancy, we can merge that, do a center, bring that in a little bit, bring that in a little bit more. We can put a border around that. Be like, but no, but that's separate. So we've got that conversion. So if we change this to 9 inches, now we know that we got 9.7. Easy way to check. Want to do simpler math, change it to 6, we're at 9.5, and so we're good to go. So we'll go back up to 12. That gives us 10 feet across there. So what we want to do as another check is we want to override the east and west. So let's do this at, let's do 5 feet. Make 5 feet 12 inches. That gives it 6 feet. That'll give us a average of 8. So if we're looking at this wall here and this wall here, the average of that would be 8 feet. So we'll be able to check that over here. So our first, what we want to do equal, and we want to multiply, we want to find the average of this. So we'll add this east wall plus this west wall, divide that by 2, and now to give us 8. So if we want to make this an average of 10, if we change this to 7 and change this to 11, then when we multiply these together, since this average is 10, multiply that times 8, we should get 80. And this is just a way to check as you go, make it easy so you know what it's going to be. So we'll do times, parentheses, we'll group this. We want to add north wall plus south wall. Divide that by 2. And if we did everything, we should get 80. Multiply that by the height. Should give us 800. Now if we go back, change all this back to 9s. 9 feet, 9 feet 12, 9 feet 12. We're at 1,000 cubic feet. So now if we need to change this, we can. I'm going to set this back to equal. Go here. And if you copy that over and then drag that down, it should track. So as we change this to 6, we should have 6 down there. And we're good to go. All right. So we've got the volume successfully. We can add the seating capacity. Now we're going to get into the actual acoustic portion of this and start adding. We want all the surfaces and then a minimum of 4 materials for each one. So I'll go ahead and put a barrier here. Make it, you can do colors. Let's do a color today. Let's say Bob Ross was doing this, so add a happy little color here for Bob Ross and his trees. Give this a label of surfaces. And now we want to add surface here. Material. Area. Let's make it small. Square feet. We can look at what that percentage is because the client might want that. And now we can do 63 hertz. We'll do all the octave bands. 125 hertz. Oops, that should be 25. 250 hertz. Only spreadsheets, new octave bands, we could do the copy. 500 hertz. 1,000. 2,000. Or and we'll do the. I'm going to come here, double click. If you highlight all this, is going to mess up the above, mess up this aspect of it. So in that case, to keep this even, I'll do Control X, and I'm gonna move it over to column N. And now if I do it, double click on these, now we've got this in. Now this is a little bit tighter, like that. Let's go ahead and call this absorption. And if you don't know how to spell absorption, we've got some tools up here. We're gonna go check the spelling, see what we need to do. Someday, yeah, let's go ahead and change that. All right. Search all sheets, sure. No spelling. Good. Good, good. Everyone will be happy with your spelling skills. So I merged these, adds absorption coefficient. Let's center that. And then we can add a line underneath here. And that kind of shows us that these are absorption coefficients. Go ahead, make these bold if you would like. Let them stand out a little bit. Make it bold. You might want to change that width a little bit. We'll change the font size. So we've got our absorption coefficients. We've got our columns for our surface, our material. We can figure out our area for that surface. What we're missing is what the Sabins are, which would be the area times what that coefficient is. But let's set up the surfaces first, and then we can go start doing the tolling, because once we do one, it's just a copy of that. So we know our base area for the east wall will be 100 square feet. For the ceiling, it will be 10 east wall times north wall. And that will give us 100 square feet also. So it should be pretty straightforward calculation. If you wanted to check it as you were going, you could change these so you know that you're not making the same area and copying them over. So we might do that. We might make the floor, we'll make these 11. And that will make those walls 144 and then 120. Be a little easier to track. And then we can change the east wall and west wall. Make sure it tracks down here. So let's go ahead and start ceiling. So make this ceiling, see if I can spell right. I'm going to go ahead and add another. I've already colored it once. I'm going to add another gray line across here. It might be a little bit too gray. Hard to see. This just gives a separation. And we'll do 1, 2, 3, 4. We need 4 materials. This is where you'd put what the material is, the percentage of that. So I use 1 as base, and then if I had a panel, I add that here. I'll show that once we get it set up. If you had a window and a door, those would be your other ones. You can do more, but 4 is what you need for now. So we need to find out what the ceiling area is. And so we do that. We don't have to do the long conversion up here. So the ceiling is just the east wall times the north wall. And that will give us a ceiling area. Now, if we want to change those where they're different, they were different, we would need to take this. Oops. Need to look down at the keyboard. So we'll take east wall plus west wall. Divide that by 2 to give us that average. Add north wall plus south wall. Divide that by 2. And we want that times. There's a problem, missing parentheses. And that is because we didn't have parentheses here. And now we got it. 144. So the way to check that is if this is east wall is 12 and the west wall is 8, that should make them 10. So it should be 120. So if we make this 7, we've got 120. So we have that correct. So if you change those dimensions, that will change what we have. So now, let's say that material oops. Where'd my there we go. Let's say I always think it's Excel. It doesn't behave the same. Override default for text there. So that is a input. This is the base. So we'll have this equal to this. So just to start. So if we have no other materials, these should be equal. But as we add other materials, you don't want to manual subtract them out. So what we need to do is do a -2, -3, -4. And then if you added a panel, let's just say it's a 4x8 panel. Oops. Absorption. That'd be 32. We change that to 32, and now it automatically updates what your area is. And now we can do percentages of that, and that's just based on the base. So we'll do 112 divided by 144. Make that a little bit bigger. Highlight all this because this will be percentages. Go change our number. Data. Oh, oops. Percent there. And we want to round that back. Nobody's going to be that precise. But we've got 78%. Go ahead and copy that down. And now we have an issue doing that because now it's moving down. Because you can see that because it's wanting to divide here. That will show you there. So if you go up to, we've got C14 is here, and we want to keep this number. So go right in front of the C13, which is the base material. Hit F4. Give you $sign. That means it won't change that cell. That cell is absolute. And as we go down, we got 22%, 0%, 0%, which is correct. If we change this, erase that out. If we change this to 72, we got 50-50. We change this 36, 36. So that matches out right. Changes to 18, 18. And it's showing 13%, which is more because it is rounding up. If you wanted to bump that out by 1/10%, to show tint. So as you can see that 0.5%, you can, or you can just know that it rounds on its own, which I will just keep it to that aspect. So we've got those percentages in. We've got the areas in. We've got 4. So all we need to do, we'll copy this down 1. I like to leave a space in there if I ever want to add one. Got our line across there. But now, because we copied this down, it's looking for something down in here to multiply by. And that's why we're getting our 0. So we want to just do this as the east wall. So we've got wall, call that east. We'll change this to painted block wall. And I'm just copying it out of another one. Keep that 4x8 absorption panel. Should probably make that 4 feet so we know. Always keep your units in. Again, want to make sure you spelled absorption correct. Looks like we got it. Search all the sheets. All right. It's always good to check that, especially when you start copying things down. You don't want to have to fix it 6 times in there. So we're going to do the east wall. So that's the length of the east wall times the height. So we can go edit that formula. That formula. So we will do height. And we don't need to do it by 2. Because we only have 1 height. If you wanted to add another height in, you could. If you had a sloped roof, slanted roof, you could do that. But for this case, we'll just keep it 1 height. And now we will do, we need to get the average of, oh, no, we don't. Because we're only doing the east wall. So this is a lot easier. Let's just get back out of that. So let's delete that. And we're just going to take east wall. So we're going to do height times east wall. There we go. Now we got 120, which matches what we expected. Painted block wall. We take this down. So if we got 60 here, 30 here. Whoops, that's not right. So the issue that we have here is we're looking at 144 because we copied it down. So this, instead of being C13, which is this cell, needs to be C19. So all we need to do is change this to 9. Change that to 9. We're at 50%. Do 30% here. Or 30. We bump that out. And have a oh, I was wondering why that wasn't working. Oops. So what I had done, let's go back and look at that, is I had manually overrid what our base is. And so that's why the base wasn't looking correct. So if you do that and go back and copy up it there, the issue here is it's referencing itself. It's trying to subtract itself out once you erase that. Now if we change this to 60, gotta copy them down. Remember we changed this one, but we didn't change this one. See, this is still C13. So what we want to do, copy that. Now if we change this to 30, change this to 30, 15, 15, we have what we had up above. This would be 12.5. So we're good to go. So we've got the east wall, we've got the ceiling. Now let's do the north wall. Change this to north. And what we need to do, if you wanted to not copy the height, because we know we're going to use the height on the next, or for 4 of them, so the next 3, we can go over to R2, hit F4, copy that down, and then now we only have to change 1, which would be, we want to do the north wall, so that is R4, change it to R4, highlights over here in purple, we know we're here, so we should have 120, and we're good to go on that. If we wanted to change this to, let's say it's only 8 feet, it's a really small room, we want to check that to make sure that this returns 80, then we're good to go with 80. Change this to 25, copy that down, change this to 40, change this to 20, change this to 10, change this to 5, 5. $20, 10, 10, and we're there. So it's matching, tracking with what we would expect up above. Go ahead and add our line across there. And just do this 2 more times. So to save the time, let's copy this because it's going to be similar. We're going to call this west now to match over there. We need to change this R15. The west wall is R6. Nope. R5. That's 120. 90. 25%, 75%, 25% should be the same. The issue is we didn't change that R19, so it's still referencing up here. So it's good to change these to make sure that they're different and they're doing the same percentages. So if we change this to something a lot smaller, let's call it 5, then we're getting 60 down here, and we know that 30 square feet is not 25% of 60. So let's Control Z that back out. We know this is an error. We know it's C19, should be C31. And now if we copy that, that is changes to 60, and we're at 50%. Whoops. Changes to 60. And we did it again up there, didn't we? I don't know why I keep doing that. So let's do this to here. We're good. So this is our base material. We don't want to change that. We just want to add doors, windows, absorption, panels to it. Make our gray line there. Make our gray line there. We've got 40 there, so that's not right. So let's check these again one more time. If you got the area, subtract the other 3. 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 Don't have that, so let's copy that down. And because we have no area here, we're down at R16. We need to be at R6. That is the south wall. We're at 80. That's correct. Down. We change this to 10. Above should be 70. Automatically calculates what we need for percentages. And we have everything but the floor. So let's do the floor. Be similar to the ceiling. So let's just take that. Control C. Skip an area. Got that. Ooh. And this is where it starts because you got to jump back and forth. Because you're getting outside of your screen a little bit. Unless you're working on a larger screen. And then, so when that happens, a lot of times I will bring those calculations down to the bottom and build off that when we get to our outcomes in the next example. All right, so we've got the issue here is we're looking at stuff down low. So this should be R3. Nope. R2. No, that was right. 3. So we've got east. We should go to west. Should be 5. And then we go 4, 8. And we're good to go. So it should return 96. And we've got 96. Now remember, this is still looking at C13. So we want to change that to 43. And then copy that down. So we got our percentage rate. So now we can use either the percentage of that wall or the square foot of that wall. Because if the wall changes and you're looking at what that finish should be, then giving that percentage is more useful. So if the floor changes from 10 by 8 to, let's go back to, or 12 by 8, let's go back to 12 by 12. You don't have to change, oops. You don't have to change your recommendations. You can still go back to what you had originally, of that being the absorption being more and not based on that square feet. Be based on a percentage, because that's what we actually want it to be, is that ratio. So we want to look at that in percentages, which is helpful. Knowing that panels come in 4 by 8, so we need to have them at 32. Change out to 32, and that's more even. So it's 20%. So if that's what we're going for, depending on the performance of that panel. All right, the last thing that we have is what's called room effect, and that's air and people. So what we're doing there, oops. That line, and then we'll call this is not text. So that's the end of our app. And so we've got cubic feet, which is good. We've got equal to cubic feet divided by 1,000. So we got 1.63. And then people in the room equal to the people up here. Because you probably know this number for your room. So let's say we've got a classroom. Say we're going to put 40 people in there. You kind of know that in that size of room. If you're in a performance space with 400, you can start with 400 there. Pull that data down here to the room effect, and then we'll add in absorption coefficients for air at 1,000 cubic feet and then a number of people. And break that out over on this side. So that's the first step. Now we've got input for absorption coefficients, and then we'll take that over to total absorption to the side here per surface. And then once we have those numbers, we can start looking at the Sabin-Ehring equations and then start backing out based on a goal. So we can set a target reverberation time, see if we're higher or lower based on our calculations and what we need to do, and then where we need to add absorption. So we're not putting all in the ceiling, all on the floor, all on one wall, and we've got that uniformity that we're looking to and building that tool. But for the sake of this example, this is where we're going to cut it off, and we'll pick back up building, adding in coefficients, then over in this area, getting total absorption and Sabins, taking that down, summing that, figuring out what our RT60 is, and then finishing up the tool so we can use it on future projects. All right. Thank you much.